How do the waves produce sound? At the end of this lesson, you should be able to explain sound as a mechanical and longitudinal wave. Describe propagation of sound in a medium. Differentiate longitudinal and transverse waves. Identify the characteristics of sound waves. Your friend YB here is going to keep you company along the way. He's going to ask you interesting questions, which is also going to hone your scholastic skills. Your friend YB here is going to keep you company along the way. He's going to ask you interesting questions, which is also going to hone your scholastic skills. We come across a lot of sounds every day. On a pleasant note, hear the nightingales sing. Here is a car moving. These are some crackers bursting. And finally, there is a favorite band playing the most desired music in the city. There is a variety of sounds that we hear. What is sound? Sound is a form of energy which produces a sensation of hearing in our ears. Hey, observe one thing. The speakers are vibrating. When touched, we can feel the to and fro movement. Look at the drums. The drum beats are peppy. There is some sand particles fallen on the drum. Look how it's moving. Why did the sand particles move? It is the vibrations of the sound from the drums which is causing the bouncing of the sand particles. How was the sound produced in the drums? The drummer uses his mechanical energy and hits the drums with the drum cords and sets it to vibrate, which produces sound. Can sound be produced without the production of vibration? Let us observe a few objects which produce sound. When you ring a cycle bell, do you feel the vibration? Yes, you do. The bell vibrates and produces sound. Place your fingertips on your throat and hum a song. Do you feel the vibrations near your throat? Yes. Human voice is produced due to the vibrations of the vocal cords. Here is a U-shaped elastic metal fork called the tuning fork, which when stroked once produces a musical note. Can you see the faint vibrations of the tuning fork? Yes, the tuning fork is vibrating. To make it more evident, let us place the tuning fork after striking it on the surface of water. The disturbance in water is caused due to the tuning fork. Let us place a tuning fork without striking it or producing sound inside water. You don't see any disturbance inside the water. This suggests only vibrating object produces sound. Can you think of how the sound from the tuning fork is heard by you? Sound from the point of generation has to move to reach the ears of the listener. Sound moves through air. The substance through which sound is transmitted is called as medium. A medium can be solid, liquid, or gas. How does sound energy travel in a medium? Sound is propagated in air, much like blowing up a large balloon which expands equally in all directions. Sound energy travels as vibration. It is very similar to passing a parcel game, where there are kids lined up and pass the parcel from the starting point to the final. None of them move from the start to the stop of the game. Only the parcel moves. Similar process happens in the propagation of sound energy. The vibrations or the sound energy is analogous to the parcel. When an object vibrates, it sets the particles of medium around it to vibrate. These particles are displaced from their equilibrium and exert a force on the adjacent particles. As a result of it, the adjacent particles get displaced and from its position of rest. The first particle comes to rest after displacing the second. This process continues till the sound reaches the ear. The disturbance created by the source of sound or the vibrations travel through the medium and not the particles, just like the parcel travels and not the people to transfer the parcel in the game. In physics, any disturbance that travels through space and time, usually accompanied by transfer of energy, is called a wave. Hence, sound can be visualized as waves. Sound waves are characterized by motion of particles in the medium and hence called mechanical waves. Movement of sound waves is compared to a slinky. Stretch the slinky to almost its full length. Have someone hold the far end of the slinky. Holding one end of the slinky in hand, Give a rapid push on the slinky followed by an equally rapid pull. This results in formation of two kinds of regions. Regions where there are more coils called the compression, and the regions where there are less coils called the rarefactions. Now we can compare this process with the sound propagation. Vibration of an object results in compression of air and high pressure. This region is called compression. This compression starts to move away from the vibrating object and creates a region of low pressure called rarefaction. As the object moves back and forth rapidly, a series of compressions and rarefactions is created in the air. Hence, propagation of sound can be visualized as propagation of density variations or pressure variations in the medium. In these sound waves, the individual particles have moved in a direction parallel to the direction of propagation of the disturbance. Hence, these sound waves are called as longitudinal waves. There is also another type of wave where the particles oscillate up and down perpendicular to the direction of propagation of wave. Such waves are called as transverse waves. Example, light waves. What happens if there is no medium? Sound cannot propagate in the absence of a medium. It cannot travel through vacuum. An electric bell is suspended inside an airtight glass bell jar connected to a vacuum pump. As the electric bell circuit is completed, the sound is heard. Now, if the air is slowly removed from the bell jar by using a vacuum pump, the intensity of sound goes on decreasing, and finally no sound is heard when all the air is drawn out. We would be seeing the hammer striking the gong repeatedly. This clearly proves that sound requires a material for its propagation. Let us look at the characteristics of sound wave. A sound wave more often is compared to a water wave. Think of the water waves that you have seen when you have visited the beaches. A wave is always famous for its up and down features. The upper portion of the curve or the peak of the wave is called as crest. It represents the region of higher particles in a sound wave, and it is a compression. The lower region of a wave or the valley is called a trough of a wave and represents the region of lesser pressure and particles, which is a rarefaction in sound wave. The distance between the two consecutive compressions or two consecutive rarefactions is called as wavelength. The wavelength is represented by lambda and measured in meters. One maximum crest and the minimum trough form one single oscillation. A wave is composed of several such oscillations. For example, in a water wave there are oscillations set up. They can be close together or far apart. If they are close together, there are more of them. They are more frequent. Hence, the oscillations determine the frequency of the wave, and it can be defined as the number of oscillations per unit time. Frequency is represented by Nu, and it's measured as hertz. The time taken for one complete oscillation is called the time period of the wave. It is represented by T. If oscillations are more frequent, it means that they have taken less time. Hence, frequency and time are inversely proportional. Our brain can interpret the frequency. Like for example, just by listening to the unknown voice on the phone, we'll be able to characterize as male or female. Why is it so? This is because of the difference in the characteristics of the sound. One such characteristic is the pitch. If the frequency is fast, then the pitch is high. Generally, females have a higher pitch. High pitch corresponds to more number of compressions and rarefactions passing a point per unit time. The loudness of the sound is determined by another characteristic. It is the magnitude of the maximum disturbance of the medium. Like for example, water waves can also be great, big, tall waves or small ripples. The size of a wave or the maximum disturbance in the medium on either side of the mean value is called its amplitude. In sound waves, the bigger the wave, the louder the sound is. There is also quality associated with the sound, which enables us to distinguish one sound from another, although they have the same pitch. A sound of a single frequency is called a tone. A sound that is produced mixtures of several frequencies is called a note and is pleasant to hear.